Hi, my name is Shafi Amri, and today I will be showing you 3 easy experiments that you can do at home. As the first experiment that we will going to do today is the red cabbage juice. First of all, as you can see, what I did was I blend the red cabbage to get the liquid juice, and then I filter it to remove the insoluble substances. As you can see, there's still some small insoluble substances in the cabbage juice. So what I did was I put a cloth and I filtered it again to remove the small insoluble particles. So as you can see, it's pure juice, red cabbage juice. Okay, right in front of me there's 3 glasses filled with the red cabbage juice. As you may not know, red cabbage juice can use as a pH indicator to identify whether the liquid is acid or base. So I have 3 mysterious liquid to try and to identify whether it is an acid or a base. Let's see, the first mysterious liquid is the Colgate or a toothpaste. The second one we got here is a soap. Third one is we got vinegar. So firstly, I'm going to pour vinegar inside the first glass of red cabbage juice. Wow, amazing! Second glass, we're going to put toothpaste. As you can see, toothpaste. I'm just gonna pour we move on to the third experiment, which is the third glass of the red cabbage juice. Wow! As you can see, guys, it turns to purple. Okay, so as you see right in front of me, this 3 red cabbage juice from blue, it turns to, for the first experiment we add vinegar, it turns to red. And the second glass, we add we add Colgate or toothpaste, and it turns to light blue. And the third one, we add soap, which turns to purple. Okay, so for more detailed explanation, as you can see, there's a pH scale where you can identify whether the color is a strong acid or the color is a strong alkali. So as you know, the vinegar is red, which is it has a pH of 0. That's why it is red. And the second experiment we got light blue. So we can say that the Colgate is around 9 to 10 pH. And the third one we add soap, we got purple. So we can assume that it is around 12 to 14 pH, which is alkali. The next experiment that we are going to do is an acid-base reaction. First, I have a hard-boiled egg placed in the glass right here, and the second one, I got a vinegar. So for detail why it is becoming like this is because firstly vinegar, which is acid, and the eggshell, or we can call it as calcium carbonate, is a base. So when it is acid, it becomes a proton donor, and when it is a base, it becomes a proton acceptor. So vinegar is likely to give proton to the calcium carbonate, making carbon dioxide as a product. Thus, the experiment will slowly eat up the calcium carbonate or the eggshell until it became so thin. It's already a day and a half, and I took out the egg and I washed it with water. And the result in the reaction eating up the calcium carbonate, it makes the egg squishy. Okay guys, for the third experiment, we are going to test for density, make an experiment for density. So what I'm going to do is I'm going to pour this water inside this glass, and then I'm gonna put a little bit flavoring so that I can separate it. Secondly, I will be putting oil. So, as you can see in the glass, the water is deeper than the oil and the oil is floating. It means that the water is more denser than the oil and the oil is less denser than the water. That's why the position of the oil is at the top. Okay, so for further explanation why the oil is less denser than the water, it's because we know that the chemical equation for the water is H2O and oil is C8H18. So as we compare the bond between water and oil, it looks like the oil has more bonds than the water. So when it has more bonds, it makes it less tight packed with each other, making it more loose and taking up more space because it has a lot. So easy, right? You can do at home, anywhere, anytime. If you liked the video, don't forget to hit that like button and don't forget to subscribe. It really helped me a lot. Bye!